Dear friends, welcome to Infos. Welcome to this video. We are continuing our sessions on valve. In this video, we are discussing about some more manual valves, mainly linear motion valve. In last video, I hope you have seen my last video on manual valves, rotary type valves. So in this video, we are discussing about manual valves, basically mainly on linear motion. So in that linear motion manual valves, the first valve is globe valve. Welcome to this video. Globe valve is a linear motion valve characterized by a body with a longer face to face that accommodates flow passages sufficiently long enough to ensure smooth flow through the valve without any sharp turn. You can see here, so linear motion means the valve is moving from top to bottom. So the stem and hand wheel and closing and opening element, flow element, it is moving up and down like this. So you can see here the flow is entering from here and it is taking a turn from here and going here. So this is flow element is sitting in the seat. So this is a simple representation of a globe valve. So it's a linear motion valve. We can see some information more on globe valve. It is used for both on-off and throttling application. That is very important. Isolation purpose also this valve is using, but in the major contribution is in the control valve area. Control valve area, this globe valve is using large, means it is regularly using. More globe valve application is in throttling area. Manual globe valves can be applied in both gas and liquid service. So application in both cases. Although service should be relatively clean to avoid particulates from being caught in the seat and creating unwanted leakage. Only that limitation is there. Slurry and too much polluted flow is there, means maybe it will create some problem in the opening and this flow element area, flow area. So that is the problem. Otherwise, it is clean, for relatively clean liquids and gases. This is perfectly okay, this globe valve. Globe valve, continuing that one, common globe valve application include on-off and flow control, frequent stroking, vacuum and wide temperature extreme. So in all cases, globe valve is globe valve can use and application is not limited. Although the globe valve body design can handle high pressure classes up to around NSI class 2500. Manual globe valves are usually applied to lower pressure application because the thrust limitation of the hand operator. So that another limitation, because the hand operator thrust limitation, it is limited to low pressure application. The majority of globe valve designs feature top entry to the trim from top to bottom, plug and seat. Here it is there, plug and seat. Stem is there and plug is there. This is the seating area. This design permits easier servicing of the internal parts by disassembling the bonnet flange and the bonnet flange bolting and removing the top works, bonnet and plug as one assembly. The largest drawback of globe valve are that it can weigh considerably more than a comparable rotary valve and much more costly. Size wise, it is not compact as rotary valve. That is the one limitation, but that is not a big limitation. Application wise, globe valves are largely using in oil and gas operation. Second linear operation manual valves coming from the linear operation is the gate valve. most commonly using valve, isolation valve is a gate valve, both in liquid and gas application, high pressure and low pressure application. In all cases, all scenarios, gate valves are using commonly. Gate valve uses a typically flat closure element here. This is the flat closure element and this is moving up and down. Element perpendicular to the process flow. See, this is the process flow. The flowing element means closing element. This one disk is moving perpendicular to the process flow, which slides into the flow stream by provide a shutoff. A clear tight shutoff is providing. This is the open and closed. From this picture you can see very clearly. Overall, the simplicity of the gate valve design and its application to a large number of general low pressure drop services makes it one of the most common valve in use today. See, so most common valves because of its simplicity and application of large number in general and low pressure drop services. So many reasons are there. Gate valves are using most common valve in the industry. It can be applied in both liquid and gas service, although it's mostly used in liquid services. So both cases is there. Majority is used is in liquid service. The gate valve was designed primarily for on-off service, where the valve is operated infrequently. Basically, in oil and gas, from my experience, it is isolation valve, on-off service, major line, and not using as a throttling valves. It is specially designed for slurries with entrained solids, granules, and powders, and cryogenic and vacuum service. Most of the cases, gate valve is suitable for using. As an on-off block valve, it can be designed for full area flow to minimize the pressure drop and allow the passage of a pipe cleaning pig. That is, in the opening area, you can get that complete benefit of the opening area. So the pig pig also can travel through the flow path. Gate valves continuing. When compared to other type of manual valve, the gate valve is relatively inexpensive as well as easy to maintain and disassemble. So this is also one of the important property of gate valves. Manual linear type valve. The most commonly applied is in simple on-off services as a block valve. Other word is isolation valve. You can see the P&ID or you can visit your plant area to see that one. You can this many gate valves are using as an isolation valve or block valve. Gate valves do have some limitations. Gate valves do not handle throttling application well because they provide inadequate control characteristics. So it is very limited in throttling application like a control valve. Gate valve, some more information available on gate valve. Gate valves are divided into two design. So this is gate valve design, parallel and wedge shaped. So this is parallel and wedge shaped is actually the gate itself. The design of the gate itself designed in a two-way, parallel and wedge shape. Parallel means straight and parallel. Wedge means the bottom upper side is diameter is more and bottom side diameter is less. That is a wedge shaped. The parallel gate valve we use a flat disc. See, flat disc means straight. Both upper side and lower side is same diameter dimension. The flat disc gate has the closure element that fits between two parallel seats, an upstream seat and downstream seat. Here, see the upstream seat and downstream seat. This is the closed position parallel gate valve. This is another picture of a parallel gate valve. For the most part, the application of a parallel gate valve is limited to low pressure drop and low pressures, and where tight shutoff is not an inappropriate important prerequisite. So that means where tight shutoff is not required, we can refer this parallel gate valve, parallel type shape gate valve. Closer element is in the parallel shape. So that case we can use that one. And another one is wedge shaped gate valve. Uses two inclined seat and a slightly mismatched inclined gate that allows for the tight shut off even against the highest pressure. See here, tight the wedge shaped is upper side dimension is slightly higher and lower side is tightly comparatively less, and it is a wedge shaped. So it is getting inside the seat properly, a tight shut off, even tight shut off and against high pressure as well. So that is the importance of wedge shaped gate valve. So two type gate valves are there: parallel type closer element and wedge shaped closer element. Difference is low pressure and high pressure and tight shut off. Gate valves are commonly found in sizes of 2 to 12 inch in NSI class 150, although larger sizes are sometimes custom designed. So application is limited up to class 150. Some more design is from gate valve. The gate is attached to the manual operator through the gate stem, which may be either fixed or rising stem to the gate or threaded non-rising stem. So the gate itself, this is the gate. Gate itself design is a two type. One is the stem is moving up and down. So gate and stem is a single piece. It is moving up and down while valve is opening and closing. The other one is in the next picture. The hand wheel will, the entire body part will move up and down, but the stem will not move up and down. You cannot see stem is up like this in the open position. Stem will be limited to here. So we can see that one. So rising stem and non-rising stem. Just to visit to the field and finally identify that one, where is you are using rising stem and non-rising stem gate valves. So the fixed gate stem does not turn with the manual operator but stays stationary with the gate. As hand wheel is turned, the threads which are located above the packing box here, threads retract the gate from the flow stream, causing the threaded portion of the stem to rise above the hand wheel here. Above rise the hand wheel. So when the opening time, and it is moving down when in closing time. Non-rising stem gate valve also here I can see here in both the case closed condition and open condition specifically showing here. See, the stem is not going, hand wheel itself will move, or hand wheel also moving, not moving here. See, it is moving here only. See, it's opening like this one. So this will move here like this. It will not coming out of the gate valve outside. With a threaded gate stem, the stem is threaded to the gate itself, turning the hand wheel threads to the stem into the gate, causing the gate to lift out of the flow stream. So that is rising stem gate valve and non-rising stem gate valve. Some more information on operation side from gate valve. With most application, unless the flow rate is minimal, keeping the gate valve in a throttling position mid-stroke result in flutter of the gate valve gate as well as vibration and unnecessary wear. So that means that in a throttling application, normally it will not use, but in some time it is using in a mid-stroke, the partially open throttling position. So these are the result in flutter of the gate and vibration and unnecessary wear. So try to avoid minimize the throttling application using gate valves. Because of the gate valves create additional flow turbulence in mid-stroke position. They are not normally specified for throttling application. It's already mentioned that one. So throttling application, gate valve is not suitable. Pinch valve, another linear motion valve, third valve from linear motion type. Pinch valve, speciality valve designed for special application and you can see here there is no a metallic type opening or closing element. Instead of that one, a elastomeric type or rubber type or plastic type opening or a closure element, and which is pressing and moving the stem from the upper side, and it is closing and opening here the flow path. A pinch valve is one with a flexible elastomer body that can be used, that can be pushed together or pinched through a mechanism or through a fluid pressure. You can see this picture, it is a pinch valve representation, pictorial representation. In most cases, the elastomeric body is simply a complete liner that lines the entire inside flow passage as well as the flanges. Here, it is the inside the body. The liner, we call it as a liner. This is the opening, this closure element is calling liner. The liner keeps all moving part outside the flow stream. Therefore, this non-wetted part can be made from less expensive material such as carbon steel. So, it is less expensive. Mainly application is in the corrosive chemical flow application. So, this is the picture, another picture of pinch valve. Because the fluid is completely contained inside the liner. See, fluid is completely contained inside the liner. The valve has an added benefit, not requiring a packing box or gasket. There is no way to a leaking outside the flow path. In other valves, it is there, packing box and stuffing box, gasket should be there. But in this pinch valve, and there is no need. So, that is a big advantage and benefit of the pinch valve. But the application is limited in corrosive area, low pressure area, very limited application. Not a commonly using valve we can see. In pinch valves, when the liner seals, the sealing area is large as opposed to a single sealing point with most valves. Because of the characteristics, large objects or particulate can be trapped in the sealed area of the valve, yet the seal can be maintained. So, this is the one of the limitation. Particulates can be trapped inside the area. Pinch valves are ideal for particle entrained fluids, slurries such as processed food, sand entrained water system, sewage treatment, unprocessed water, granular flows, etc. So, many applications are there in for this pinch valve. Another type of valve is a diaphragm valve. It is also linear motion valve. Almost same like as a pinch valve, but some difference is there. Let us see how diaphragm valve is working. This is the open position, this is a closed position, and closure element is also diaphragm, a flexible plastic, rubber type, elastomeric type material using, and the same pressure is applying from the upper side on the operation side, manual operator side, then closing and opening the valve. Related to pinch valve, diaphragm valve uses an elastomeric diaphragm instead of the liner in the body to separate the flow stream from the closure element. When compressed, the diaphragm is pushed against the bottom of the body to provide bubble tight shutoff. That is very important word, bubble tight shutoff. It's providing that one. Application is specialty valve using in the corrosive and chemical applications. This is the diaphragm valve. The closure element is not wetted by the process and therefore can be made from less expensive material in corrosive process. That is very important application of a diaphragm valve. The flow stream is straight through or nearly straight through. Flow stream, see, straight through or nearly straight through, providing a minimal pressure drop which makes it ideal for on-off service as well as avoiding the creation of turbulent flow. Limited is its throttling application is very limited. On-off valve is regularly using, but a specialty valve in special cases. Because of the diaphragm is contained in a pressure retaining body, a diaphragm valve is able to handle somewhat high pressure than a pinch valve. That is important, high pressure than a pinch valve. Although the overall pressure and temperature rating are depend upon the flexibility of the material, that diaphragm, or reinforcement of the diaphragm. The diaphragm depend upon the diaphragm, the temperature and pressure application is dependent. Diaphragm valves have an application similar to pinch valve. The resilience of the diaphragm allows it to seal around particulates in the fluid, making it ideal for service the slurry, processed food and solid entrained fluid. This is another picture of a diaphragm valve. Opening on the depending on the design, diaphragm valves are applicable in larger size than pinch valve, typically up to 14 inch to ON 350, although some special design can go up to 500 ON 500 or 20 inch. Because of the pressure limitation, the diaphragm valves are nearly always rated ANSI class 150. It's limited, that one, so up to that pressure. So that is the design part. ANSI is based on classification. Some more informations are available on diaphragm valve. Two designs are typically associated with the diaphragm valve. The straight through design and weir type design. The weir type diaphragm valve has same construction as the straight through except the body and diaphragm. So almost both are concept, but very minor difference is there in the design. You look at that one, weir type design. This is the weir type design. A flexible diaphragm is there. So this is the lower body is slightly moving upper side and giving a tight shut off. The body has a raised lip, that is the word which is using, that rises to meet the diaphragm, allowing the use of a smaller diaphragm. The body is designing a self-draining, which makes it ideal for food processing application. So another one is straight through. You can see there is no upper highlighted lift or lifted lip, not there. It's a body is the bottom, so it is closing this way. This is the way. The diaphragm is a slightly different design. The straight through diaphragm valve has a body in which the bottom wall is nearly parallel to the fluid. See, nearly parallel to the fluid stream, allowing the flow to move uninhibited through the valve with no major obstruction. That is the important one. The flexibility of the diaphragm allows it to reach the bottom of the valve body. So it is the flexible diaphragm is reaching up to here. So the closure element design is slightly different. This is the picture of diaphragm valve, straight through type. The diaphragm itself is used as the gasket between the body and bonnet cap, and prevents leakage to the atmosphere. So this is another. There is no other gasket using here for like gate valve or globe valve, etc. So thanks for watching this video. Next lessons are coming. We have covered most of the valve classification, design, characterization, linear type and rotary type manual valve, etc., etc. So here next session or video is covering on non-return valve, check valve, then pressure safety valves. That is another lesson is pending and including. Control valves also, that is a very important valve in a process industry. So these are the next few coming lessons or videos. Thanks for all support, and subscribe this channel if you like this channel. I hope you have liked this channel and support this one. Subscribe and share to your friends. And here we are adding our end card or list of all list of videos in the as a list here, and the next video also coming in this session, and as an attachment, so you can easily go for the next video. So in each video from the first video itself, it is continuation is there. You can watch it that one. Thanks for watching this video. Have a good day.